So Krishnaji, did you want to start and then I'll take over, or do you want me to just go full speed ahead?
Yeah. So I will update to those guys also, to you also. So what we did, actually we thought yesterday there is a session, so we actually came together everybody, and then we realized that you were invited from Tuesday. So what we did, we utilized yesterday's time. I actually given a 1 hour session to them, whatever I know, the basics of NSO, what is Yang, what is netconf, and how NSO actually pushes configuration, what is the similarities or with the Arjalato, how we do it in Arjalato today, and how NSO is actually doing that in a better way, and what are the differences and all. So they will actually able to realize that how the NSO fits into the entire ecosystem. So that is what we covered yesterday. That is just to actually give basics, so they should not actually see that as a very new thing today. Previously, around some 2-3 months back or some more time back, they actually studied Yang also at some level, but we can start at zero. So over to you. I actually told them that 3 days we will conduct the session. We have a laboratory setup available, and you will give them a good solid homework. Remaining 3 days, Friday, Saturday, Sunday, Monday, these guys will do that homework, complete the exercise, come up. Then when you will come on Tuesday again, you will actually review that, understand who faced what issues, how much they are able to complete, what issues they have faced, and then we'll actually take it further to the next module. That is what I updated to them. If you want to do any change, suggest anything, you can go ahead.
Now that's good, Krishnaji. It's good that you gave them that introduction. So some of what I will talk about today might be a repetition of what Krishnaji has already told you all, and some of it might be new. And again, it's a high level, just so that I want to make sure that everyone is on the same page. So we will go from zero and start from there. Now, in terms of the lab, I have set up some lab. The only thing that is required for that lab is connectivity to the Cisco corporate network. So I'm not sure, Krishnaji, how that's going to work. Let's talk about that offline, but it's on the Cisco network, so we will have to figure out people if they have access to it. If not, then we'll have to figure out how we go about and do that. So we'll get started. Hello, everyone. Glad that you can join. My name is Bilal Alam. I'm based in Sydney, and I have been, in my past life, I was a software tech lead at Cisco for 14 years in the business unit, doing platform code for various routing platforms like 7200 and ISRs. And for the last 3 years, I have been in the pre-sales team selling the product called NSO, which stands for Network Services Orchestrator. And Cisco acquired a company in 2014, in the August of 2014, called Telef. And the company is a Swedish company from Sweden, and they had 2 products. One is called ConfD, and the other was called NCS. And because Cisco already has NCS platform, we had to change the name. So the same NCS product has been renamed to NSO. So if you go on YouTube and you search for NCS and you find Telef NCS, it's the same thing as Cisco NSO. So there's a lot of videos in the public domain, and there's a lot of documentation in the public domain that you can also check out if needed. So that's the history about the company. So the Telef company was acquired 3 years ago, so now it's a full-fledged part of Cisco. And Cisco has been using the NSO product in a lot of projects, and we have software offerings where we have used NSO as the core platform to build new software offerings, such as virtual topology system, VTS, and we have NSO embedded in a lot of different software projects. We also have conf-D, which is a slightly different product, embedded inside. We're starting to embed that in our operating systems like iOS XE and some of the other software modules like Elastic Services Controller. We have the other module conf-D. Today's presentation is going to be about NSO. We will not talk about conf-D, but I'll give you one line, one sentence description of what conf-D is, so that just you know. But most of the time we will talk about NSO for this week and next week. So conf-D is basically a module that a manufacturer, an equipment vendor, an equipment manufacturer can use conf-D inside their operating system and allow device programmability. So in the past, it was really difficult to configure a device, let alone program it. We had to use some sort of screen scraping and templates, and we log onto the device and then do CLI. So conf-D basically becomes a part of the operating system like iOS XE or Junos, for example, or different vendors are putting conf-D inside their platform. And what it allows to do is it allows the device to be programmable. So we can then, once conf-D is embedded in the operating system of the vendor, then the equipment is programmable via a whole suite of API interfaces like netconf and REST and things like that. So that's conf-D. So let's get back to the main product, which is NSO. And, we can have a Q&A while we can keep it interactive, but I would request people to go on mute. If they're not talking, then and I'll request people to go on mute. Let me just. Okay. So I will mute some people, and if you want to ask questions, then feel free to unmute yourself. Okay. So let's get started. This is the agenda. What I'm going to show you today is, about service provisioning. The whole topic is about service provisioning, service activation, service provisioning. And one of the questions that would come to your mind is, what exactly is a service? Now, from an NSO perspective, anything can be a service. It could be automation of the infrastructure. It could be VPN. It could be NFV service. NSO has got no hard coding. NSO allows you to take any service and automate it. So it's like more of a platform offering. It's not a prescribed sort of solution. And what I'll show you with NSO is that if you're using templates and if you're using scripting to do your automation, to do your activation, then using NSO, you will be able to achieve the same result, but 90% faster. Right? So this is what we're going to discuss. How can you all use NSO and go 90% faster when compared to a traditional template and script-based approach, right? So it's a big improvement in productivity, and that's what we'll cover. And that's why Krishnaji wants you all to hear about NSO and look into it a little bit deeper to see how we can get that 90% productivity increase by using NSO and how we can apply that for our customer like Reliance, okay? So we're going to talk about the old way of doing things and how we do it in the new world of orchestration. We're going to talk about, there has been a lot of different orchestration tools from time to time. Why is NSO different? Why should we really care? And in that respect, I'll talk about a model-driven approach. So that's the differentiation here. NSO uses what we call a model-driven architecture. So we'll go into more details as to what is a model-driven architecture and what benefits it provides. And then once we talk about that, the next stage is, can the platform do the automation that we want to do today? And also, can it do automation for future use cases for future technology, right? So how is the platform future-proof? Because when we give it to our customer, we do some use cases for them today, but tomorrow they have new technology, you know, they might want to use virtualization, or they might want to use containers, or whatever, they might want to use public cloud, or whatever it might be. How do we make sure that the platform that we put in for the customer can solve their problem today, but also be future-proof, right? And then the whole concept of service centricity, you know, everything that I'm going to talk about is going to be about service, and the service can vary a lot. Everyone has got the different problems that they're solving. So, you know, one person's service might be an infrastructure service. We've got customer using NSO to program up robots in a warehouse, for example. We've got customer using it for smart grid applications. So there's no limitation. The limitation is really the creativity of the service designer. And one of the other things that I'll run over is use cases, just to show you a whole lot of variety, a whole lot of different use cases that customers are using NSO for. And we have more than 100 customers now, and these are big customers, the likes of AT&T, Verizon. In Australia, we have Telstra, Vodafone. We have almost every big service provider in Japan that is using NSO. And they're doing a lot of different things. They're doing physical automation. They're doing NFV. They're doing cross-domain orchestration, infrastructure turn-up, and a whole lot of different use cases. So we're going to talk about, I'll show you some of them, just to demonstrate the flexibility of the platform. And then you can use your own creativity and think about cases where you can use NSO to automate your use cases that you have been using scripts and templates in the past. So that's the agenda, and we've got a lot of time. We've got next 3 days, and then next week, as I mentioned, there is a lab, so you can get your hands dirty where you will install NSO, you will do some device programming, then you will build a brand new service, and then you will implement that service on a multi-vendor environment. And then you would do CRUD operations on the service, create an instance, delete an instance, update an instance, and then you will go ahead and update the service schema, because, you know, nothing is set in stone. We want to be able to change some of the service schema, and then we provision existing instances and update existing instances, and you'll see how easy it becomes when you use NSO. Okay, any questions so far? Okay, I think we're good.
No.
Sorry, was there a question?
No, Bilal.
Okay, we'll continue.
Yeah.
So, before I jump into NSO, it's good to understand the problem that our customers are facing. And look, you all know it really well. You know, a lot of this is well known. We have built these networks. You know, all of us are really good at building networks. We have built these networks, and over time, these networks have become really complex, and they have multiple domains, and they have different platforms. Sometimes they have multiple vendors. And what has happened is that now that this network is in place, if you want to get a particular outcome from this network, it's really hard. The reason why it's really hard is because the network is so complex. We have a whole suite of provisioning system, activation system, EMS, NMS system, and a whole bunch of CLI all over the place. Now, if you want to design a new service, so say one of your service designer, they get a really good idea, and they want to design and bring a new service to the market, it's really hard for them because of the complexity of the network. So the network becomes the bottleneck. And it's usually two big problems that we have. One is adapter tax, which basically means whenever we have a new vendor or a new platform or a new operating system or something in the network layer, we have to pay in terms of time and money to integrate with that new network element. It could be a physical network element. It could be a new technology like an SDN controller, whatever it might be. But whenever we change something in the network layer, we have to pay a huge adapter tax in terms of time or money or both, right? And then when we bring these services or change these services on top of this network, the other tax that we pay is what we call integration tax, which is integrating the service, network service, with our OSS and BSS, right? So there's a lot of integration work that's required. Now, every time we change something in the network, you know, we have to pay a hefty adapter tax and also a hefty integration tax. And currently the way the network is, everything is slow and error prone, especially if you want to do a cross-domain activation. If you want to do something between two domains, then you do it in one domain, and then you go to the operator in the other domain, and you say, hey, by the way, this is the VLAN. The packet is going to come tagged in this VLAN, so can you take that? And this is for tenant X. There's a lot of manual provisioning. There's a lot of spreadsheet everywhere, just trying to correlate information between domains, right? So there's no single source of truth, right? So this is the problem that we have, and this is almost every service provider across the globe. So this is not new. I mean, we find this at Telstra, we find this at Optus, we find this everywhere. So, you know, a service provider has to be really unique if they don't have the same problem, right? And the way that we have been building services doesn't scale. So, you know, the way we build services is vertically stacked. It's very tightly coupled. So every time we make a small change, we change a device or a platform, everything has to change. We have to change our scripts. We have to change our OSS, BSS. We have to change our, you know, every small change in that stack percolates all the way up the stack. It goes all the way up the stack. And, you know, we have to pay a whole set of adapter tax and integration tax. So it's very brittle. Every small change breaks the entire stack, right? Or we have to spend a lot of time reintegrating and making sure the new device works, and you know we have to reintegrate everything. So it's pretty expensive at the moment. It's very fragile, and that basically slows down innovation. So every time we want to change something or bring something new, we have, you know, it doesn't provide us with any agility. And you know, there's implications of that. If you want to design a brand new service, then you know it takes very long. And this is a service provider in the U.S. You know, when they have an idea of a new service that they want to take to market, it takes them 300+ days to take an idea to production. So that's a very long time. And if you look at the web scale companies these days, you know, 300+ days, you know, is no longer competitive. We can't really be competitive in the marketplace if we take an idea and it takes us a year to bring it to the market. Even after we have designed the service, in order to take orders and activate those orders, it can take us weeks, right? Sometimes 2 to 4 weeks to activate an order, especially if it's a cross-domain outcome. And again, you know, our customers, they're used to instant activation. The end customer, the tenant, Reliance's end customer, they want to come on a web portal and be able to activate and make changes instantly. So, you know, gone are the days when we can tell our end customers that, you know, things would happen in 2 to 4 weeks. It's just not acceptable anymore. The other problem that we face is there's no single source of truth. If we have a problem in our network, say you've got a customer, I'll take an example. In Australia, we have a car company called Holden. Maybe we can call Maruti in India, right? So we say you have Maruti, and they have VPNs and sites all over the place, and they call you and say, my site X cannot access the application running in your data center, and you want to debug that, right? So at the moment, we don't have a single source of truth. We have the WAN domain, we have the data center domain, we have the access domain. How do you find out what's broken? There is no way to find out, you know, what all devices were touched, and for each one of those devices and each one of those domains, what exact configuration was pushed to each one of those devices. And if that configuration has been tampered with, did someone go into one of these devices and did they just tamper the service configuration? So there's no easy way to make that determination. It takes a very long time, right? And similarly with troubleshooting and assurance. So I won't go too much into assurance in this topic, in these sessions, because it's a topic in itself. We will stick mainly to provisioning, activation, provisioning, real-time auditing of the services that we have provisioned in our network. These are some of the concerns that we will tackle first before going into assurance. Maybe that's a topic for another day or another session. So the very first thing that NSO allows us to do is the separation of the service layer from the network layer. It's the decoupling. And this is important because now we can start thinking in terms of service. So this is really what matters. This is how all of us get paid, right? Our innovation is to offer services which our end customers can consume. But the problem is all of us spend all our time just to keep the lights on at the network layer. Just all our time is sucked in just to manage network configuration, device configuration, making sure things are, the policy is being complied with. If someone hasn't gone and changed config, something's broken. So we have lost focus, and NSO brings the focus back towards services. So whenever we go to the network, we never go directly to the devices. We always build these use cases or the service abstraction, and then we consume the network via these service abstraction, via these service packages, right? And we have a design time and we have a run time. So in design time, we design these services, we test these services, and at runtime, we just instantiate these services. So at runtime, we take orders from the northbound system, and then we just go ahead and push the service instances onto the network, right? And we have a clear separation between the service layer and the network layer. And this allows us to innovate at different speed. So, a service might offer layer 2 VPN or layer 3 VPN, but the way it's implemented in the network might change, or it might even be a hybrid environment. We might use physical assets or virtual assets, for example, in our network layer. We might use virtualization, or when containers becomes more prevalent, we might end up using container. But we don't expose all that network level detail into our services. So, basically bringing the focus back to services. And the sort of things that NSO...
Yeah, Bilal, a quick question here. So,
Sure.
Because we are doing this abstraction or separation, at some point of time, we have to be aware of the bridging, right? The connection between the service and the endpoint or the target device on which it is going to get deployed. Say, for example, an inventory of a device, whether it has sufficient number of ports or not. So how does this awareness or the bridging between the two comes in?
Yeah, so, one is designing the service, and then the next step is mapping that service to the network layer. So, what we're doing is we're saying, here's a service layer 3 VPN. How does it map to my network? Now, when we do that mapping exercise, we put validation, and there's multiple levels of validation. We can put validation in the services definition, and I'll go into more details, how we define services in Yang, and then we can have Yang-based validation. So this is more like at design time we put these validations. And then at runtime, when the service is being implemented, is being mapped, we have something called a service mapper or a service create callback. And again, we'll see that in the lab. At this time, we can do pre and post validation. So, as part of the NSO service definition, we have the service schema definition, which defines the service, what the service is about. And then we have another part which is called service creation callback, where we define how that service is being mapped. And as part of that creation callback, we can do some more validation. And what validation?
So in a nutshell, yeah, what you're saying is it doesn't have to be, and this is for the benefit of the larger audience, right? NSO as a service deployer, right, doesn't have to be aware of any inventory or state of the inventory, right? It can be configured as a set of plays, as part of the mapper or the schema, right, as pre and post validation for every step that is to be executed as part of the service configuration.
Yeah, it could be both actually. You could, and it's really up to the service designer. Do they want to embed the
inventory information as part of the service, or do they want to pass it down from a northbound system? So there is multiple options there, and we can explore some of them during the sessions. We have seen cases where, for example, we want to spin up a service chain. Now, where do we spin up the service chain? So, we have things like, let's look for a data center that is least loaded, or let's look for a data center that is closer to the customer so that they get good latency, or we can make those validation and decision making as part of the service creation mapping, and we can go into more details. But you're right, Girish. There is these validations that need to be put in place, and the service designer would have to think from the start, where's the inventory information going to come from? Is that information fed in from the northbound system, or do we want to look it up at runtime? So, things like that are good questions, and we will look into some of the options there. But the whole idea of the slide is that, whenever we think about a VPN, if I say VPN, layer 3 VPN, most of the people in the room would think VRF, or routing instance, or route import and route export. So straight away, they're thinking in terms of device configuration, right? So what NSO allows us to do is, when we think about VPN, when I say layer 3 VPN, the things that come to your mind is, okay, what's the start point, what's the end point, and am I doing, what's the connectivity? It's like we really build the service construct first, where we go, okay, what is the outcome that we want to achieve? And then we map it to the network reality. So what I'm trying to say is that sometimes we have a tendency to go into the details really quickly and device configuration. And what we have to do is step back a little bit and start thinking in terms of use cases, and start thinking in terms of services, and then build these in Yang, and then map them to the device configuration. And that's the process. And then we'll go
so Bilal, in the lab. What you're saying is, just help me understand this correctly, right? What you're saying is, instead of really looking at, what a VPN would look like from a device perspective, we look at VPN from a service perspective, that a VPN means it should have minimum 2 endpoints, right? There could be more, but say the first rule of the game says it should have 2 endpoints. And then based upon the flavor of the VPN, if it is a mesh or a hub and spoke, maybe we have further more complexities added, that in a hub and spoke VPN kind of configuration, the hub side configuration should remain constant, and only the spokes should get added as and when, and should get deleted as and when. Because if the hub is deleted, everything else falls apart.
Correct. And so just using that example, Girish, when we design a service like layer 3 VPN, and we have, for example, a list of sites, right? And then in the list of sites, we might have a marker which says this is a hub and this is a spoke, or something like that. So that's the way I would think about a service. Instead of me thinking about VRFs and how do I do this and that, sure, we will get to that, but it's important to keep that separate. The reason being is that once we design this service, today we might use, VRF or whatever to implement it. Tomorrow we might end up using another way of doing the same outcome. So the services are more outcome-centric. What is the outcome that I want? And what are the parameters that I need to get that outcome? So layer 3 VPN is I want a VPN with multiple sites. So that's the thinking, and you'll see more examples of that, right? I mean, the last thing we want to do is start exposing device-level details into the service layer. One of the things that you will see is, as we go through this process, is we try to simplify the services. We try to make it simple. We try to make it intuitive. We try to keep the number of parameters required as minimum as possible. And we don't try to expose everything into the service, right? And this is a difficult thing because as engineers, we have a tendency to revel in details, right? So trying to hide complexity and exposing intelligence is, it's difficult at times, but that's really where the industry is headed. Let's think about services because 80% of the time, the end customer is not interested in all the, details of the device configuration. 80% of the time, they have a pretty high-level view of what the service outcome that they want to get, right? It's only the 20% of the customers that they might say, no, I want to do my VPN in a particular way, right? I want to do my security in a particular way. What I'm trying to say is that for 80% of the cases, we can automate them. And for 20% of the cases, which might require very bespoke configuration, which might not be as conducive for automation. But anyway, let's go into more details. But generally, the idea here is the separation. We want to decouple the network layer from the services layer. And NSO actually forces you to do that. And we'll see more examples of this. Okay. So, you might be thinking, most of you guys in the room have done a lot of provisioning and activation. You've done a lot of scripting and templates, and you probably know networks better than I do, right? So you must be thinking, what's the difference with NSO? We've tried this multiple times. We've got all these tools. How is NSO different? So the first key differentiator is a model-driven architecture, right? And what does that mean? Model-driven architecture. So if you have done software, and most of you probably have, then you are aware with the notion of data structures, right? So if you do your software if you do programming in C, then you're aware of a C struct, for example, right? If you've done your programming in C++, then you're aware of a class definition, right? Or Java, you're aware of a class definition, right? So a model-driven architecture or data models is like a data structure, right? So in a data structure, you define an entity is an integer, and an int it's 16-bit or 32-bit, depending on how big the number is going to be. If it's signed or unsigned, if it's a string or an array of characters, and if it's in C, you have things like pointers and things like that, right? So that's data structure, right? So data models are like data structure. So what we do with NSO is step number one, the first step, and the way I will build the functionality of NSO is bottom up. So I'm going to start at the bottom, and I'll move up towards the top. So let's start with the network layer. So what we do with the model-driven approach with NSO is that we go and model the entire network. So Cisco has built a data structure of your entire network. So, and just think about what that means. So that means, you can have all these devices in your network, and you have a data structure representing every single device, every single line of configuration of every single device in your network. So we have a data model, and a data model precisely captures, this is an interface, and this is an MTU under an interface. An MTU is an integer, and it's a 16-bit integer, for example, and it can range from value X to value Y. So that's the level of precision that we have gone to model the entire network. And this is not just for Cisco, this is for Cisco and Juniper and all the different vendors that you can find. It's not only for iOS XR devices or Nexus devices or XE device. Everything is covered. Not only are the conventional network elements covered, like your routers and switches, but also we have a data model for new breed of non-conventional network elements like SDN controllers and VNF managers and EMS and NMS. Cisco has gone and built a data model, a data structure for all the different things that you can find in your network layer. So imagine that now your entire network is presented to you as a data structure, as a really precise data structure. So no longer you have to do screen scraping and parse and guess, what something is and hope for the best. Rather, you're getting a very precise view of your network in real time. So at any time, you can go and say, hey, what is the configuration of my network? And you will get back a data structure for every device showing you the config line by line in a very precise data structure format. So that's what a model-driven approach means. And it takes a lot of time, but
question here. Yeah. So, one
Sure.
was the time. Second was, would it be just one model, or would it be a set of models that would be required to comprehensively and accurately describe the device or the network element?
Good question. Yeah. So that's what I was coming at. So the way we do that is with NSO is we want it to be modular, right? So this is where the industry is headed. We don't want one big, huge monolith piece of software, right? Because the problem with that is it's hard to maintain, it's not agile, it slows down innovation. So what we've done with NSO is that when we build these models, we package them up, and each of the packages is called a NED. And NED stands for Network Element Driver, and we'll go into more detail. So we have one NED package for example, Cisco iOS. We have another NED package for Cisco Nexus operating system. We have another NED package for Juniper Junos. We have another NED package for example, the APIC controller, right? So because sometimes you might want to use an APIC controller in the ACI mode, and you might not want to go to the devices in a standalone mode, right? So it depends on which mode you're in. So we have a NED package for APIC, which has got the model for the APIC's configuration space. We have a NED package for Nexus OS, which has got the model for the Nexus command lines and CLIs and whatever that might be. We have a NED package for iOS. We have a NED package for XR, and so on and so forth. So you can see how it's very modular in that way. And each NED package has got its own repository. So you can drag and drop the NED package that you need. You don't need the NED package for everything. You only need the NED package for the devices that you have in your network, right? So you just get that. And if you find a bug in a NED package, we only have to update that NED package. So it's very modular. So it's sort of like drag and drop. And you decide to add a new platform, a new vendor or a new platform, then if you don't already have the NED package in your environment, you just go and get the NED package for the new platform and you drop it in your environment. You don't have to reinstall NSO. You just drop that package in the NSO's runtime packages directory, right? So you just drop that package and you can start using it. So it's very modular in that way, and it's manageable. So it's not like a one huge big model. Rather, the model is incrementally built by one NED package at a time, and you pick the NED packages that you need. Girish, was that the question? There were two parts. I think I've answered one of them. What was the other one? I forget the first part.
Yeah, is it just one data structure? I mean, one model, or could we need multiple data structures to comprehensively describe the device, right?
Yeah, true. So no, it's not one data structure. That's a good point as well. It's like a family of data structures, right? So it's like.
So what you're saying is, for example, each routing protocol could be one data structure. BGP could be another. Okay.
Correct. That's right. Yep. That's correct. Yeah. So it's like just like when we're doing a software, we have like depending on the different notions that we have, we might have multiple classes, and we might have in C language we might have multiple struct. Where it makes sense to do so, we define these data structures, and you will see that Yang is pretty rich. It has the notion of a container, a list, and things like that, which allows you to define different things and organize them in a nice way, right? So that's the way you have these NEDs. And when we do the lab, you can actually you can go into the NED package itself, and you can see the model. You can see the model for that NED, right? So it's all pretty open. It's not like we try to hide the model. So the models are pretty open, and you can have a look, and you can have a browse around. Now, these NED packages are supported by Cisco engineering, right? If someone changes the NED package, then Cisco engineering will not support that NED package, right? So that's how it works. So we have these repositories. And the thing is, the licensing model is such that it's very cheap to build these NEDs. Not building that, sorry. It's very cheap to get these NEDs for a customer. It's around $40,000 US, $50,000 US. And there is no notion of a change request. So usually when we have adapters, we have an adapter tax. Every time you want to make a change, the vendor is going to go, you got to pay for that change, and they charge you a whole bucket of money. With NSO, the way the NED works is once you pay for the perpetual license, you don't have to pay adapter tax again and again and again. If you have bugs or if you want to have enhancements, it's covered, right? And these NEDs, they go in a centralized library, and we share it with all our customers. So that's the way it works, the NED. And it's, if no one, once you look at the cost of a NED, because it's so low, there's no point building the interfaces to the devices. There's no point writing scripts and doing screen scraping on the devices, because the NED gives you a very precise interface to that device. And the amount of time it will take you to write interfaces to the device is going to be very costly. So, you defer that to the NED, and the NED manages all the device communication for you in a really nice way. So you no longer have to worry about, how do I connect to the device? How do I do a no on this submode or that submode? None of that. You get a really clean model for your device's configuration space, and then you can configure your device using that. And as we go through these slides, you'll see that you will actually never use the device model. You will actually always use a service model. So when we apply the model-driven approach, these NEDs, each one of them have got a model for the device, and we call them the device model. And you'll see in a second what a service model is. A service model is actually the services that we build on top of this platform. So that's the NED, and each of these NEDs have got a device model, and these device models are done using an open standard modeling language called the Yang. And there is an RFC for Yang. It's RFC 6020, so it's pretty open. You can go and have a look how the Yang works and what are the different constructs that we use to describe a Yang model. It's all in the open, right? So there's no sort of proprietary there's no proprietary portions to this, right? And so basically, once we build the NED and give you the NED package, then it doesn't matter whether you're consuming like an APIC controller, or whether you're consuming a VNF manager like Elastic Services Controller, or whether you're consuming a Cisco router or a Cisco switch or an XR router. It doesn't matter. Everything becomes a Yang. Everything looks like a Yang. Everything, the way you would consume it, is Yang. So you no longer have to write a script and then you go, oh, if this is iOS, then look for this prompt and wait for this long and then do this and look for these error message. You don't have any of that. You get a nice data structure for your entire network, so everything becomes a Yang. So this, you can see, is pretty revolutionary. Your entire network is presented to you as a Yang model, as multiple Yang models. And then you don't have to worry about, do I do a REST call? Do I do a SOAP call? Do I do a TL1? Do I do CLI? Do I do generic? I mean, SNM, it doesn't matter. It doesn't matter what the southbound interface to the devices. Everything is presented to someone sitting on top of the platform as a Yang model, right? So it really simplifies how we go to the network and how we consume the network devices. It doesn't matter whether something is a physical device, or if it's a virtual device, or if it's a controller. If it's today you might be using OpenStack, tomorrow you might be using Kubernetes. Everything is presented to you as a Yang model. So this is how the platform is future-proof. The new technology comes around, new vendor comes around, new platform comes around. All we do is build a new NED, and you would consume it in exactly the same way via the Yang data model for that device, right? So this is how.
So Bilal, yeah, question, right? When we say the controller or any domain controller for that matter, we are even abstracting away underlay set of devices that are managed by that controller, right?
Correct. So just recently we were talking to a bank in Australia, and they have a use case where they want to program up their physical devices in their premises on-prem, and then they have some devices in a cloud exchange provider, which is in a POP, right, in a cage. So they have a cage, and then they use the cloud exchange provider like Equinix to go out to public cloud like AWS, right? And they want to do the entire stitching. So I spoke to the BU, and the BU said, we will build a NED for Equinix. So now if you want to do, instead of calling APIs from your scripts to Equinix to do your connectivity from your from your cage in the Equinix POP to the AWS cloud, instead of calling APIs, Equinix APIs, calling REST APIs, we build a NED for you. And then you just use that NED to program up the Equinix. And then we have a NED for AWS. So you use the NED to spin up, for example, workloads in EC2, for example. Right.
So essentially, then the bank on-prem, Equinix, and AWS essentially become a service chain, correct?
Yeah, so it becomes like you get a data model for it, and then you build a service model on top, and the service model then maps to all these data models, right? So it might map to the data model for the on-prem devices, it will map to the device model for Equinix, and it will map to the device model for AWS to get the desired outcome. So the service model is what we expose to the end customer or the consumer who wants that outcome. We don't expose the underlying details. We say, here's a service, and the service basically goes, I've got a workload in my on-prem, and I want to connect it to another workload in my off-prem, or in the public cloud, or something of that, connectivity, or whatever it might be. I don't know. But we define the service in such a way that we don't expose all the underlying details. So, the consumer of that service, the operator of that service, doesn't have to go log on to Equinix and push commands and REST calls and go to AWS and management console and do more stuff. They have one centralized place, and they have a centralized service construct and a use case, and then they say to the service, hey, service, here are the parameters. Can you go ahead and now configure all the different domains so I can get the outcome that I want? So this is really how it all fits together. And it'll become a little bit more clear when we go through some of the use case. I have the plan to go through some of the use case where we actually go into the code, we do the code walkthrough, and then you'll see how this mapping takes place between the service layer and the device layer, right? So far, we've only covered the device layer. All I've told you is that your entire network has become a Yang model, and you can now go to your network through the Yang definitions without worrying about the individual southbound protocol, whether it be CLI or SSH or netconf, could be netconf, or REST or RESTconf or SOAP or TL1, whatever it might be. You don't have to worry of that. You get a nice Yang representation of your entire network. So that's step number one, right? So that's step one, as you can see. And here's an example of what a device model is. It's defined in Yang, so you get very high precision, right? So that's one of the things. In templates and scripts, you don't get that precision. You just push configs. It's like text. You're pushing text. You've got no visibility of what's on the device. You just push more configs on top of the device, and you hope for the best, right? If there's a problem and you have to remove the configs, then again you have another script to remove the configs. So it's really, Yang is very different. Yang is giving you a data structure representation of your network. So very precise. And I've just, you can visualize a Yang model as like a folder structure. It's like a folder, a hierarchical folder structure. So you have your tree. It's like a tree structure. You have your nodes, sub-nodes, and so on and so forth. And it can be as deep as you want. So on the left, you have an example for, of a device model A, and you can have another device model B, which can look really different. But that's one way to visualize it. When you see some of the Yang models, it's good to visualize it like a folder structure or like a tree structure, and it'll be good if you can visualize it like this, right? And the Yang is used to define the schema, the data structure. But what do we do with data structure? We instantiate. If it's a class, we instantiate objects. So the objects is the data, right? And in C, we have struct, which defines the schema, and then we actually have struct instances. So those instances, the data is, we usually represent that in XML or JSON, right? So that's as per the definition in Yang. So that's some of the terminology. Yang is for the schema. We define the schema using Yang. But when we then deal with data that abides by that schema, that conforms to that schema, then that data is usually represented in XML or JSON, okay? So we can think of Yang as XSD. So if you want to see like a comparison, XSD, which is the XML schema definition, okay? So that's really what Yang is, and then the instances. So for example, we have a device model for iOS. So that defines the data structure of the iOS configuration space. Then we have device 1, device 2, device 3, which are iOS. For device 1, we will have one instance of that model, right? Because we'll have data for device 1. And then for device 2, we will have another instance which has to conform to the same model, the device model, and so on and so forth. And then similarly, we have device models for XR and Nexus. So the devices for those operating system, the data would have to conform to the device model, to the device schema. So just a terminology thing, but it's important to understand the difference between a model, a schema, and the data. It's sort of like a table definition in a database, and then we have rows in the database that abide by the definition of the table, right? So the rows are the data, and the table is a schema. Similarly, Yang is a schema, and then we will have data which has to abide by the Yang definition. Any questions? Okay. So what we have here is a network element driver. As I mentioned, we can have NED packages. And if you look inside one of these NED packages, there are two parts. One is called the declarative part, and it's in red for a reason. And the other one is called the functional part, the logic part, which we call the NED engine. So the declarative part is actually the Yang model. So this Yang model of the NED represents the configuration space, the data structure for that respective device, right? For that device or that operating system. So I have taken a snapshot of iOS device model. I've just taken a cut and paste of, for example, the gigabit Ethernet. So it's a list. List means you can have a lot of different elements. And then down here, you can see that because it's a list, to uniquely identify an element in that list, we use a key, and the key that we use here is the name, and then that name refers to that leaf over here. So this leaf over here is the key for that list, and the type for that leaf is a string, and that string has to conform with that pattern. So if a value is supplied and if the name doesn't match that pattern, then that would be rejected. So I'm just showing you just one element in your configuration space. This has been done for the entire configuration space for iOS, right? Similarly, we have gone and modeled this data structure for XR and Nexus. So you can see how detailed it gets. One of the things that you will realize is that as part of this model, we don't write how to set the name or how to unset the name or how to change the name. All we do is we declare that this is a name, it's of type string, and this is the pattern that it follows, right? And similarly for MTU, we'll have a leaf called MTU. It's of type uint16 for unsigned integer 16, for example. And we can have, instead of pattern, we have another keyword called range, and we can say these are the range of values that the MTU leaf can take, right? So we're just declaring it. We're not saying, how do I set the MTU or how do I unset it? I need a no command over here at this submode, none of that. We just declare the configuration, right? That's what we do in the iOS device model or any device model for that matter. So that's the declarative part of the NED. Now the functional part, which is called the NED engine, what it does is it can take the declarative part and then push that down to the device using the device's native southbound protocol. Now because this is iOS, the native protocol is CLI. So what the NED engine can do is it can take that model data and then it can push it down to the iOS by converting it into a sequence of CLI and push it down over Telnet or SSH, right? So that's what the net engine does, and vice versa. The net engine can read the configuration from the device, like show run config, show running config, right? And it will parse that according to the declarative model and store it in the configuration database of NSO, right? So there is a configuration database in NSO called CDB. So the net engine can read that and parse that according to the model and store it in the database. So that's what the net engine does. Once the net engine is done, then the only task is to incrementally keep increasing the device model. So say a new feature comes along. Say, in iOS, a new feature comes along. We don't have to go and change the net engine. 99.99% of the time, we don't have to change the net engine. All we have to do is go to the YANG file for that net and just declare the configuration, like declare. We don't even have to say, this is how you set it, this is how you unset it, this is how you update it. We just declare the configuration. And the net engine then knows how to set that, unset that, update or delete anything in the configuration space, right? It knows how to do that on the device by talking the device's native southbound protocol. Now, for iOS, that would be CLI. So if this is a net for APIC, for example, then in that case, the APIC's net engine would then call the REST API calls on the APIC controller, right? And then it would get the managed objects from the APIC, EPGs or whatever contracts and bridge domains, and it would parse it, and then it would present that to NSO as a YANG model, as per the YANG model, and that would get stored in the configuration database, the CDB of NSO. So every net engine is purpose-built specifically to that particular vendor or platform that it's talking to. The YANG model is, again, it depends on that platform, on that operating system. The YANG model captures the configuration space of that particular platform. So the iOS YANG model is the iOS configuration space. It captures in a declarative way. The iOS XR YANG model captures the configuration of the XR devices. The Nexus YANG model would capture the Nexus's configuration, right? So that's how it's all put together, right? And this YANG model and this net engine, usually done in logic, usually done in Java, and the declarative part done in YANG, they both are packaged in the one net package, right? So that is the iOS package, and then you'll have an XR package, and then you have ALU package, ALU SR operating system, for example, Juniper Junos. And this is what you'll do in the lab. You'll have multiple nets. You'll have a net for iOS, you'll have a net for XR, a net for Juniper, a net for ALU, net for Huawei, and you'll build a multi-vendor service as part of that lab, right? Any questions? Okay. We'll keep moving. Now, this is just the list of nets that I have here. This is actually a little bit old, but it's to illustrate the point that, so far we have not found one thing in the network layer that we cannot build a net for. So we can build a net for everything. We can use YANG to represent the configuration of anything that you might find in your network layer. All that we require is connectivity to that entity, if you can connect to it. If you can send sort of messages to it, whether it be CLI, that's okay. We want to be able to send some messages to it and get some replies, right? And we need to have a notion of a configuration space, show running config. There has to be some notion of configuration. If we have all those three things, then we can build a net. We've got customers that were trying to poke a net for a robot, which was doing some optical cabling, for example, right? We have a net for EMSs and NMSs and controllers. So we have a net for a whole range of things. It's pretty flexible in that way. So NSO allows you to consume almost anything in your network layer by using a YANG representation for it, right? So it's, that's the power, one of the power that NSO gives you. So here you can see, all these different platforms, ALU, Cisco, Sienna, Brocade, and a whole range of platforms. Under Cisco, you can see APIC, ASA, iOS. And this is page 1, and this is an old list. If someone is interested, I can send a more recent list. This list is updated almost every month. Every month we have some of these nets, they get updated, or we've got new entries on the list. And you can see iOS XE, XR, and then you can see on page number 3 here, Nexus, net for CPS, net for ASR 5K, WSA, Citrix, F5, Fortinet, Huawei, Juniper, Palo Alto. And now you start seeing net for non-conventional network elements, something like a net for Open Daylight, a net for OpenStack, a net for VMware, a net for Xenos, right? A net for Open vSwitch, right? A net for Juniper Contrail, so that's like a domain controller, right? A net for Big IQ, which is the controller for Big IP, the F5 equipment, right? So you can see how the net could be for anything you find in your network layer. It doesn't have to be a traditional, conventional network element like a router or a switch, right? If I go to the next page, you see the net for AWS, net for ALU SAM. That's an EMS for Alcatel, right? And here's the fun bit, right? If a customer comes along and says, we want a net for vendor XYZ. So Cisco can add a net in 4 to 6 weeks. So if you need a new net, we can add a new net. Actually, not 4. It's actually the general guideline that we give is 2 to 6 weeks. We can add a new net for a given set of use cases, for a given subset of the configuration space of that device, which is relevant for the customer. So the customer might be trying to do something interesting using a particular vendor. So they might not need coverage for the entire configuration space. For example, we don't need to model AppleTalk on iOS. iOS has been around for ages, and it's got all these different features. We're not going to go and model every single thing that iOS has, especially AppleTalk. We will only model stuff that are relevant. So, if a net doesn't exist on the list, we can add it on to the list in 2 to 6 weeks. If a net already exists and we need to update it, a new feature comes along, or a feature that we want to use is not already modeled or declared in the net, then we can add it to the net in a week to 4 weeks. Right? That's for existing net, a week to 4 week. For a net that doesn't exist, 2 to 6 weeks. And again, you don't have to pay change request, right? It's a fixed cost. You have a fixed cost for net, a perpetual license. And after that, you can keep coming back and keep getting the updated net. The nets are almost released every week or every second, whenever there's a need to do so. You don't have to wait for like 3, 4, 6 months to get a new net. You just get whatever net you want. You find a bug or an issue or enhancement, you raise a ticket in the TAC, and then TAC would get the net updated, and then you get a new net, just that net package. So it's pretty modular in that way, right? Okay, so now that we've got the entire network layer under control, this is what NSO really, this is the revolutionary bit. The modeling of the network layer was important and was critical, but when it comes from a really breakthrough, what NSO gives is it helps you to move up to the services layer, right? So you're no longer bogged down at the device layer, at the config layer of the devices. You can move up, and you can get a network-wide view if you're sitting on top. You get a single source of truth. Your entire network, you can know the configuration of your entire network with surgical precision from a single source, right? From one source. And this NSO allows you to get cross-domain outcomes, right? So you can go across domains. Sometimes you might want to have a service which might require configuring something in domain 1 and something else in domain 2 and spinning up some VNFs in domain 3 and stitching it all together. So now you can get that end-to-end outcome from a single touch point, from a single pane of glass, right? And the way we do that, and I mentioned that to you earlier, is by building these service packages. And when you install the platform, there are no service, it doesn't come with any service packages. You can get all the nets that you want from the library and put it in your platform under NSO in the runtime directory, but NSO doesn't come with any prescribed services. It comes with a lot of examples. You can pick those examples and you can use them. There's layer 3 VPN examples, there's layer 2 VPN examples, there's NFV example, security example, but we don't force these services on our customers. Rather, we go to the customer and say, hey, Mr. Customer, how would you like your VPN service to look like? And we can build as per the customer's requirement. Instead of forcing the customer to do their VPN in a particular way, we actually talk to the customer, get their requirements, and then we do services as per the customer requirement. Now, you'd be thinking layer 2 VPN, layer 3 VPN, they've been around for so long, they've been standardized. Surely we can have a common model for them, and definitely you can. There's examples there that can be used, but this is more relevant for the new breed of services, new things that you want to automate, right? So you can build these services as per customer requirement. The platform actually encourages you to do that. The platform, some offering in the marketplace might say, no, this is the only way you do VPN. This is the only way you do port turn-up. This is the only way you do whatever, right? With NSO, we say, you choose how you want to do your service, and NSO would give you that 90% efficiency. So you'll be 90% more productive if you use NSO, and we'll go into that, and you'll see why I keep claiming that you can go 90% faster compared to if you were using a script or a template-based approach, right? And as I mentioned, when you define these services, again, you do them in Yang. So we use the Yang models for services, just like we've used Yang to model the device layer, the network layer. Similarly, we use Yang to model these services. We describe how these services are going to look like based on our requirements, the customer's requirement. And there's no hard coding, right? And these services then become the intellectual property of the customer because the customer has done the requirement and the customer has built it. Obviously, the customer would use people like yourself to build these services for them, but the intellectual property falls back to the customer. Unless it's like a shared package that you guys might want to build a shared package which you might want to use for many customers, right? So there is definitely scope for reusability. NSO allows you, reusability. That's a big thing in NSO. We want to be able to design services in a way that any reusable component can be used for many services, not just one, right? So that's actually a good design choice to have reusable components, and I'll go into more details how that's done. And you can see that, the services, inside the services, you don't have scripts going all the way to the device. Rather, we have a loosely coupled mapping from the service model, which is done in Yang, to the device model, which is also done in Yang. So we have what we call a mapping between the two. And we can have mapping to one vendor, or we can have mapping to multiple vendors. We can have a mixed environment, and all that is possible when using NSO service, when building services in NSO. And we'll go through more details, as to how this all fits together. But this is just to give you the high level, the separation, and how each of these services, again, have surgical precision because they're all defined in Yang as well. The services are defined in Yang, the device models are defined in Yang, and we have a really precise mapping from the service model to the device model. So you can see the precision all the way from service model, really precise mapping to the device model, and then the device model itself are, again, in Yang, right? So they're really precise. So you can see how at all times you have complete view of your network. At all times, in real time, you have complete view of all the service instances that you have in your network, all the device configuration that you have, and the mapping between the two. So at any time you can come and say, hey, for my service, layer 3 VPN for Maruti, for example, show me the devices, domains that were touched, show me the devices that were touched, show me the configuration for each of those devices that were touched, and vice versa. You can go to any device on this in your network, and then you can look at any configuration CLI on that device, and you can trace it back to which tenant and which customer it was configured for. So you get traceability, top down and bottom up. So that is the benefit of a model-driven approach, that precision, that real-time view of your entire network, that ability to be able to consume anything and everything in a standardized way by using Yang. So no longer do you have to build these custom scripts and adapters, which are really expensive and very expensive to maintain, right? So it's not only building. Building is actually quick and easy. The real cost is actually the long-term cost to maintain and sustain it forever. That's the real cost. And what we do here is with the NEDs is we make that into a fixed cost. We say, every single net is 50K. Once you have that, then you don't have to worry about the interfacing. That's the problem of the Cisco engineer from the net engineering team, right? They will make sure it works. If you do something in the Yang model and it's not pushing the right config to the device, then you raise a ticket and that gets fixed. It's not your problem anymore. So you're really going from your network layer to your services layer. And then you're really innovating at that services layer, because that's what we all want to do. We want to innovate and bring new ideas to our customers, whether it be internal customers or external customers, right? So that's really what we want to do. We don't want to get bogged down just to keep the lights on. And that's what NSO is, that's what it's giving you, right? That's the power that you get with NSO. Any questions? I just want to take a quick check and just want to make sure that this is relevant. I just want to make sure that this is something relevant for you guys, and we're not off the chart here, off the track. I mean, you know, I'm building towards how it all fits together, but it was important to put the high level in. You know, what is the end game? Why should you all be interested? As I mentioned, the main reason why you all should be interested is because you can go 90% faster. But any comments so far?
Hello, Bilal.
Yep.
Bilal, I have a question. Like, in case of it will push the config, like service config, it will push. If I need to check some parameters related to the config, so can I get that with some show commands through Yang model also?
Definitely,
okay.
Yeah, definitely.
So if I need some intelligence in that part, like.
So when we do the lab, this is exactly what you'll be doing. At any time, you can come and you can do a show command, or you can do an API call, and we'll go into more details where you can get full visibility. You can come and say, you know, my customer Holden, show me all the devices that were touched for Holden or Maruti or whoever the customer might be. And then you can go to the next level and say, show me the configuration for Holden for each of these devices, PE1. Show me what was on the PE1. Has someone gone and tampered the configs on PE1? If they have tampered it, how have they tampered it? Show me the line-by-line diffs, things like that. So you can do, you get that level of precision with NSO, and this is something you'll see in the lab as well. When you do the lab, you will actually be able to do the show commands and see the configs for your devices, for your services, the connection from your service instances to the device configuration, right?
If I need to check some parameters on the network side, on the like services side, if I need to check something on particular customer wear up, that it is getting the internet connectivity or not. So can I do that with some show commands through Yang model, and it will show me some flags like this is done. This device, this site has the internet connectivity, but the other site, B site, doesn't have the internet connectivity at the moment. So can I do that with the Yang model? Yeah.
Sure, definitely, right. So, you know, and this is a topic that we can go into as well. Let's see how we go with the lab. But what we do is, when we build these services, layer 2 VPN, layer 3 VPN, or it could be an NFV service, or it could be a security service, then whoever the service designer is, you know, in their mind, they know how to check if the service is working or not, right? They know in their mind. So, for example, if you do it today, you push some templates and scripts and all that, and then you have all these test commands that you do on different routers. You might do ping or trace route or whatever, ping from every side to every other side, things like that, right? So in NSO, because you have your entire service configuration in the database, right? So you know all your PE routers that a particular customer is using. You also know the devices, and you have your entire device configuration in the database. You can do things like, as what we call a Yang action. So when you design your service, you also add some operations with that service, operations that you think are relevant for that service. So that one of the operation could be an activation test. You take an order from Maruti, and you provision 15 sites for them, and then now you want to do an activation test. You want to, before you call Maruti and say, hey, your sites are all up, you want to make sure it's working, right? Now, traditionally, we would go and do ping, and it really depends on the operator. They have their own cheat sheet, and they might do some funky tests and all that and make a determination and say, hey, the service is working. And then you call the customer and say your service is working, right? What we do in an NSO environment is we define the service in Yang, and at the design time, we also think about what are the common operations that we would do on this service, right? It could be activation test. It could be a health check. It could be some sort of SLAs that we want to abide by, right? Based on the service, every service is different. So depending on the service, there might be certain things that the service designer thinks make sense. So then you define that in your Yang as an action, right? And that becomes part of your service package. So once the operator is activating a particular order, and then they want to make sure it's being done, they call the action and say, hey, can I run the activation test? And the activation test would automatically run and do whatever it's meant to do, and then it'll give you back a report saying green, 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 red and orange, for example. And then you can go and do more actions and figure out why something is red and orange. But that's generally how we do that. We add actions in the Yang model for the service. And the implementation of that action is very service-centric. It's up to you guys to define what those actions are and what those actions do, right? Because that is up to the service that you're actually working on at the time.
So,
and NSO allows you to go out. Yep, go ahead.
No, you can go ahead. Yeah.
I was saying that NSO allows you to push configs to those devices, and if you want to go on a device and issue some show commands or exec commands, then NSO allows you to do that as well. And then we have another piece which we might go into, something what we call orchestrated assurance, where we set up probes in the network at different places, and, IP SLAs and things like that, reflectors. We switch them on critical places, strategic places, and that's another way of making sure whether the service is running or not. We make use of probes and reflectors and things like that to validate that the service that we've configured in the network actually works before we hand it off to the end customer.
Okay. So it will be like from between Yang and device, that will be netconf, and between the model, OpenStack model or any other model, between them that will be XML, or it will be something other than that.
Yeah, we'll go into more details on that, but generally you would be sitting on top of NSO like a northbound system, OSS, BSS, or whatever that might be, or a portal. That portal would call an API on NSO. It'll call an API on the service, whatever service it wants to create or update or delete, right? And there's a choice, right? It could be done using REST. It could be done using netconf. It could be done using JSON RPC. It could be done using RESTconf. It could be even done using CLI by logging into NSO and doing it with CLI or web UI. So there's choices there, right? Then what NSO does is it would take that request, service request, and it would use the mapping. Remember we were talking about mapping. It would use the service to device model mapping to figure out the configuration that needs to go to the network. Once it figures out the configuration to go to the network, then it would use the NED engine in those respective NEDs to push those configs to the network element. Now, if the network element is an iOS device, for example, then the NED would use CLI over SSH to push that config. if the device supports, like is the APIC, for example, APIC controller, then the net would use a REST, like a HTTP connection, and then it would call the REST APIs and configure the APIC according to the desired outcome. And if the net, if the device is using, I don't know, netconf, then it will use netconf. So that's, it doesn't matter what the device supports as an interface, NSO can work with anything and everything. And that's important because a lot of the other tools in the marketplace might come to you and say, hey, I can help you orchestrate as long as every single thing in your network is netconf. Now, that's a really hard thing because, our customers have spent all this money and they have all these assets, and we can't go to them and say, hey, throw away all your legacy stuff and make sure all the devices that you buy is netconf. That's not going to work. No one's going to buy that orchestration solution. With NSO, what we say is it doesn't matter whether it's legacy CLI, whether it's netconf device, whether it's REST, SNMP, TL1, it doesn't matter. We will build a net for it, and the net engine would take care of that conversion and translation. And if you're sitting on top of NSO, then everything looks like a model. Everything can be accessed via API, right? So that's really how it fits together. So the choice of protocol, it varies depending on the OSS BSS system. There are choices, as I mentioned. There's heaps of different API options there. And when we go to the NSO goes to the device, again, it really depends on what the device supports. If the device supports netconf, perfect, we'll use that. If the device doesn't support netconf, then we build a net, and we can use whatever the device supports, whether it be REST or SOAP or TL1 or CLI or whatever that might be. Any questions? Does that make sense?
Yeah, sure. Yep.
Okay. So let's do another 10, 15 minutes, and then we'll continue tomorrow, and hopefully we can get into a little bit more detail, right? So what I'm going to talk about now is how do you build your service today? This is how you do it today, and then we compare it with NSO. And then you will see why you can go 90% faster, okay? So today, if you want to build a service, let's take an example of Layer 3 VPN. You want to build a Layer 3 VPN service using scripts or templates or whatever orchestration tool that you might have, right? So the first thing you do is you figure out the configuration that you need to create that service. So you see the capitals, the red C. So we're talking about create. So you have a script that helps you create that service on the iOS XR device, right? And then if you have a multi-vendor or a multi-platform environment, then you will have another script to do the same create on that other vendor or platform. So in this case, I have an example for iOS XR, and on the right, I have an example for Juniper Junos, and if you have ALU and Huawei, similarly, you'll add more and more scripts. So you will need one script per vendor or per platform to do the create. Okay, this is just the create. The next thing you'll do is update. All the time you have to add new sites, we have to change bandwidth, and we have to do a lot of different stuff. So we always need, we always need update, right? So let's look at update number 1. Update number 1 might be adding a new site. So you'll write a script to do an update number 1 on XR, and then you will write another script to do update number 1 on Juniper Junos, for example. And then you might, depending on the number of platforms, you need, if you have 4 vendors or 4 platforms, then you would need 4 scripts for update number 1, okay? And then you have update number 2. The update number 2, just for the sake of example, is you want to change the AS number. I don't know why you want to do it, but for whatever reason, you want to have an update which way you want to go and change the AS number. Now, for update number 2, similarly, you'll need a script to do update number 2 for XR, and then you'll need another script to do update number 2 for Junos or another platform, and ALU and Huawei, right? So basically, if you have 4 platforms, then you would need 4 scripts to do the create, right? And then you would need another 4 scripts to do update number 1. And then you would need another 4 scripts to do update number 2. So if you have 5 or 10 types of different updates, so you have another update for example, bandwidth, right? So you'll have, another 4 scripts to change the bandwidth for the different platforms or vendors. So say if you have, let's make it simple. Say you have 10 different types of updates that you want to do, and you have 3 different vendors, then you would need 30 scripts just for the update, 3 scripts for the create, right? So you can see how this gets pretty complex, right? It gets exponential as soon as you start going to get into a multi-vendor or a multi-platform environment, right? Especially if you're doing a hybrid situation, right? If you're doing a migration from one to the other, where you want both to work for a window when you're moving from old to the new. So, there's a window where you have both of them in your environment. And then lastly, you have the delete. So you have to write a script for delete. You have to write a delete for your XR, then you have to write a delete script for your Junos, and you have to write a delete. And, depending on the sites and this and that, so you can see how it can get a little bit tricky, and it can get pretty complicated pretty quick, right? So you all are aware of this, how the template works and scripts works. Now imagine with the new type of services, and we'll see some in our demonstration. I'll show you some examples where it will be NFV service. NFV is like virtualization, service chains and things like that in the data center, and stitching it up with your physical MPLS environment via some sort of DCI router, for example, data center interconnect router, right? Now, if you look at an NFV service, the problem actually becomes even more hard. It's actually exponentially more complex. Just to create the service, you have to think about OpenStack and uploading the images and creating networks, and then making sure that the VNFs come up, right? And when the VNFs come up, you might go and get a coffee or whatever and come back just to wait and make sure the VNF is up. Or you might use Elastic Services Controller, which can provide you with, if the VNFs are up or not. So they go green. So the VNFs are up. When the VNFs are up, only after that, you have to go license them. Once they're licensed, then you have to push the create configuration, which might require routing and interface and a firewall. And, this is an example from Palo Alto where they're doing some pinholes through a firewall and doing web filtering. So not only do you have to spin up the VNFs, you got to wait for the VNFs to come up. You got to service chain them in the right way. Then once they're up, then you have to log into each one of these VNFs, just like you log into devices, and you got to configure. Your script has to configure the create, and then you has to do the update, different types of update. And imagine if you want to change your service chain as part of an update. So you can see how the way we design services right now, it doesn't scale, right? I mean, it's just too hard. It's too complicated. It's what we call, using a traditional approach. You would need to hire people from university graduation up till pension, because it's a never-ending and a thankless job, right? It just goes on and on and on. Once you have all these scripts, writing the script is easy. We all know the more scripts we have, the more lines of code we have, the more bugs, the more maintenance, the more issues, the more headache, right? We all know this. So, so the traditional approaches, the complexity grows exponentially, especially when we moved into NFV and SDN, where things are changing very quickly. It's no longer the day and no longer the case where things happen once a month or once a year or once in 6 months. Now with NFV, we want to spin up, spin down in real time and configure firewall and add a policy, remove a policy in real time. Our customers, they want instant activation. They want to come on a portal and be able to change things on the fly, right? So you can see how where this is going, and a traditional approach doesn't work, right? It just won't be able to scale. And this is where NSO comes in. The way we design services and the way, once the services have been designed, the way we activate services is very different. It's actually very, the way NSO does it is very disruptive in that way. And let's talk about that a little bit. So this is the platform, and the platform, and I'm giving you a little bit sneak preview into the internals, and we'll go into more details for each one of them. But what you will see is that we have this packages directory where you can drag and drop your packages, your service packages that you build. As I mentioned, you build your own service packages, the device packages, the device models, the NEDs. Cisco will provide all that. There's some utility packages that Cisco provides. Again, as I mentioned, we don't want to reinvent the wheel. There's certain packages that are reusable, utility packages. You can have your own in your environment, stored away in your Git repositories, or you can, Cisco has got some utility packages, problems that we see again and again and again. So we build utility packages for that, which you can use. Things like Resource Manager to do your IPAM stuff, to do allocations of IP addresses and VLANs and route targets and route distinguishers and things like that. We have packages for plug and play. If you want to do plug and play, zero-touch deployment of your CPEs, then we have plug and play package. So all these things that are very common, we build utility packages. So all of these are packages, and they are decoupled from the core software, right? So this is the core software in the rectangle, and they're all outside that. So no longer is the one monolith system. Everything is a module. Everything can be updated independently, and drag and drop sort of approach. And it's open and modular platform, right? Open in the sense that, we don't discriminate what you have in your network layer. We don't care if it's Cisco, Juniper, Alcatel, different Cisco platforms, whether you're going directly to the Nexus or via APIC, whether you're using EMSs, we don't really care. It's up to you, your choice. Once you make your choice, then NSO helps you get you that outcome on top of this, of your network layer, right? And it gives you device programmability. If you want device programmability, you don't have to build service packages. You can actually, if you have a legacy device like iOS or, something like that, and the only interface is CLI, using NSO, you can sit on top of NSO. You can actually program an iOS device sitting underneath NSO using netcon or REST or JSON RPC. So that's, what happens is, netcon, REST, and JSON RPC, all these APIs can be used to basically change and do CRUD operations on any of these models. Once you have a model, then all these APIs, they become available, and then you can use that to configure, any of these models, whether it be device models or service models. So you can, and actually some customers are using NSO just to program their devices. Previously, they were writing scripts to connect to the device and configure devices. Now they put NSO, and they can actually program their device using APIs, right? And NSO gives them a lot of benefits like transactionality, transactional guarantee, traceability, automatic rollback on failure. So, they want to just put NSO, and all of a sudden the entire network becomes programmable, even if the devices were legacy devices, right? But the real value of NSO comes from the network-wide service programmability, right? So you're building these services, and then you're programming these services. It could be machine to machine, or it could be using any of these northbound interfaces. Okay. The other thing that I want to mention is that as soon as you drop a model, as soon as you drop a service package or a device package or a utility package, all the northbound interfaces that you see here, and there's more, they get automatically generated. So as soon as you drop a new service package, you've built a new service package, automatically, automatic, auto-rendered, you don't have to write a single script. Automatically, the REST API for your service, the netconf API for your service, the RESTconf API for your service, the JSON RPC for your service, the Java and Python binding for your service, if that's the way you want to do it, the CLI for your service, the web UI for your service is automatically generated straight away. And it could be any model, as I mentioned. It could be service model or device model or utility model. As soon as you drop that model in NSO, all those interfaces are automatically generated. So whether you have a management application or whether you have network engineers sitting on top, NSO caters for all the different audience types that you can have in your network, in your environment, right? So that's a really big saving of your time. You don't have to write northbound interfaces. It's automatically generated. And these APIs give you all CRUD functionality. When I say CRUD, create, read, update, delete. Using these APIs, you can do a create of your service. You can do an update of your service. You can do a delete of your service. You can do a get to read your service. So you get all your CRUD calls for all the different families of APIs that you see, auto-generated as soon as you drop that model in the packages directory. Right, so that you can see how much time you have saved, right? And these APIs are all transactional, and I'll go into more details of what I mean by transactional, and that saves you a lot of time. It saves you from having to write a lot of error code. So generally when we have an error, when you're doing a template, you're pushing stuff and say something goes wrong, right? So you have to write error handlers. How do you recover from an error? With NSO, you get automatic rollback on error, automatic, right? So you don't have to write scripts after scripts to deal with error condition. You're trying to push a service which touches 5, 10, 50 devices. One of those devices fails for whatever reason, then the entire change set is rolled back and your network is back to where it was, right? So you go back to where you were. So that's also very powerful, right? Because then, you basically don't have to write a lot of scripts for your rollback. You don't have to write a lot of scripts for your error handling. Any questions? Okay, now generally, and this is why you guys are here. Now, to be able to use the platform, we really need two personas, right? Two personas. One person is a service designer. And generally, the service designers are people who are good at software. They've done software development in the past. They're strong in abstraction-based thinking. They can hide complexity and expose simple service models. They have done some sort of object-oriented approach, so they know how to compartmentalize, have clear demarcation between packages, and be able to break down a big problem and apply object-oriented concepts, just like we do when we design our classes. Where do we demarc? How do the classes interact with one another, and things like that. And familiarity with data structures and programming logic, right? Any programming logic is fine, because once you know one programming, you can pretty much easily pick up another one without too much hassle. Similar with data structures. Once you know some common data structures like list and array and strings and hash and binary trees and mtry, once you know these, then they're applicable to all the different programming and logic options that we might have. So similarly with NSO, right? And then you need the network architect and the network designer. Because the network designer is the person you can go to and say, this is the outcome I want from the network, and the network designer and the network architect can then tell us how that outcome is going to be realized on the network. For example, they might say, you need these devices in these places, and you need to configure these features, and you need to do it in this way, and then you have to push these CLIs to these devices. So this is really what the network designers do, and the team. And that's the team that we need to be able to use NSO. And generally, if you're doing templates and scripts and all that, then generally you already have these expertise, right? So NSO would be pretty natural to you to be able to use NSO. Okay, so now what I'm going to do is, you remember how we spoke about the layer 3 VPN example and how we had to do the create scripts Then we had to do update 1 script, update 2 script, update 3 scripts. Then we had to do the delete scripts. Now let's compare how it works in an NSO environment, right? So the very first thing that we do in NSO is, when we're doing a service package, because everything has to be put in a package, is we do the service model. And the service model, when we do the service model, there's 2 key design decisions. One is, what is the outcome that we're trying to get? Let's focus on the outcome. Without getting into the specific network level details, let's focus on what is the outcome that I want, number one. And number 2 is, what are the parameters, minimum set of parameters that I need, that I absolutely need to get my outcome, right? And that defines your service model. So a service model is the outcome that I want and the minimum set of parameters that need to be passed by a northbound system, whether that be operator or machine-to-machine by a northbound system, right? So that's what a service model is. And we purposely, and that's intentional, we try to keep the service model agnostic of device level detail. If you are exposing VRFs and routing instance, for example, if you're using Juniper in your service model, then that's generally not a good idea, because we don't want to expose device level details into the service model. We would like the service model, if possible, to be device agnostic, vendor agnostic, platform agnostic, and even technology agnostic if possible, right? So if you can do all that, then that's a really good service model, and I'll show you why that is how we should be doing it. You'll see that in a minute, right? So once you have the service model, some of the things that you would do is you'd think, do I need to add that field in my service model protocol, or can I infer that? Can I default that? Or can I read this from somewhere else? Can I get it from a pool? Can I get the IP address from a pool? Can I get the UDP or VLAN from a pool? If you can auto-infer it or auto-generate it, then don't put it in your service model. The whole idea is to keep the service model as minimalistic as possible, and that's the trend these days, right? We want to be minimalistic. The less parameters that we have in our service, the less complexity we expose to our operators, and the less chances of the operators shooting themselves in the foot, because they get the service, they look at the service model, and they can intuitively figure out how the service works, because there's only a handful of parameters, right? So that's the general idea, obviously, when the devil's in the detail, but that's the general idea. We want the service model to be agnostic of the device level, the network level details, and we want it to be more centric towards the outcome and the parameters that we absolutely need to get that outcome, the minimum set of parameters, right? So that's step number 1. And then what we do is, remember that we have a device model from the NED. So say this service, we want to implement that service on a Cisco iOS. So we take the iOS NED, and as part of that NED, we get a device model in that NED, right? And the service model is what we have just created. The next step that we do is we do what we call a creation mapping. And the creation mapping is, given the set of input for the service parameters, how do I arrive at the values for my device model, the nodes in my device, right? And it's sort of like going from the left to right, right? We're sort of drawing lines from the left to right. So this is the input, the rule, and this is where it goes, and source IP goes over here, and UDP goes into the source port of the device model, and the protocol goes into the protocol of the device model, right? So it's sort of like saying, given the set of inputs, this is how these inputs fill up the spaces in my device model, right? And, we call this FastMap. This exercise of mapping from left to right, we call it FastMap. And this mapping can be done in XML. But sometimes to do this mapping, we might need some logic. We might have to manipulate or transform or massage the input before it can go into the node on the right. So, sometimes we might have to use some logic to do some transformation or massaging or validation or whatever that might be to go from left to right. And all that is part of the fast map, right? So basically the creation mapping, we do a fast map where we map the inputs from the left to the nodes on the right. And then now say we put this service on NSO and Maruti comes along and says, okay, I want one of this. You put in the values and you say commit. And when you hit the commit button, NSO would use your creation mapping. It will use that fast map mapping and it would arrive at the values for the nodes in your device model. And then the net engine would then take those values from your device model and push it down to the device, right? So that's what the net engine does. The net engine can take the model and it can push the configuration to the device, right? So that's what the net engine does. And this is called fast map, right? So you put your values in on the left and they get mapped to the nodes on the right, and then the net engine pushes it to the device. Device or devices, could be many, one or many. And a fast map can be expressed in XML, so we can do this mapping in XML. That's what we're going to do in the lab. And as I mentioned, if that mapping requires some logic, then we can express that logic in Java or Python, right? And there's another language called Erlang. So you can express that logic in one of these three. You can even use, the XML is usually to represent data. It's not a language where you can do a whole lot of logic. There might be some logic you can do, but not a whole lot. Using something called XPath, we can do some logic in XML, but it's really, trying to shoehorn logic into XML. It's not the right tool for the right job. So whenever you want to do logic in NSO and you're doing your fast map, then you would use Python or Java, right? And Python is the choice because it's pretty precise and it gets you up and running really quickly. So that's the creation mapping. Now, what's fast about this fast map? You might be thinking, what's the fast bit? So the fast bit is this. Once you have provisioned Maruti in your network, and then you come back later and you want to change a parameter. You want to do an update. You want to do an update 1 or an update 2 or an update 3. You might want to update any of the parameters in your service model, right? So you might want to, Maruti might come and want to change their bandwidth or anything of that sort. So in NSO, you don't have to write another script. It uses the same one creation mapping to infer the changes that need to go to your network, right? So this is where you're getting your 90% saving. You don't have to write script after script after script. You just have to write one mapping, the creation mapping. Once you've done the creation mapping, the create and the update and the delete and the redeploy of your service is automatically inferred from your fast map, right? From your creation mapping. So it could be any of the parameters in your service. If you change UDP, NSO would know what needs to change in your network. If you change rule, it can figure out, it can compute what needs to change in your network. You can change one parameter at a time. You can change all the parameters at the same time. NSO can use the same creation mapping to infer what needs to go to your network. And you can even do a dry run. So before you make some changes to your service, and you're happy with those changes, before you actually push it to your network devices, you can go, give me a dry run. Show me how it's going to look like. Even before you push it to the network, it'll give you line by line, device by device, line by line, dry run as to how the change is going to go to your network. And what FastMap also does is FastMap minimizes the changes that need to go to your network. So when you make a change in your service, FastMap can compute the minimum diff, the minimum delta. It can compute the minimum diff that needs to go in your network. So instead of removing, if you make a change, instead of removing all the BGP and all the routing and everything and then making the change and then pushing it back as you would do with a template-based approach, With NSO, it automatically infer the minimum changes that are required in your network, the minimum amount. So your network can converge a lot faster, right? So that's the benefit of FastMap. From the one creation mapping, it can do your update. It can automatically do your update. It can automatically do your delete. It can automatically do the redeploy for your service instances, for your Maruti and for your Holden or whatever those service instances might be, your tenants. Right, and that's a really powerful feature of NSO, and Cisco has patented that. So Cisco has got a patent for FastMap, which is, from the one creation mapping, we can automatically infer the update, delete, and redeploy. So you don't need scripts, update 1, update 2, update 3 scripts, or delete one, script for your service, right? So that's really what FastMap does. Any questions? So, this slide basically compares NSO with the traditional approach. As we were talking about the layer 3 VPN example, you would have to do a create service flow, a create script, and then you would write scripts for, modify parameter 1, modify parameter 2, modify parameter 3, then you'll have another script for delete, and then you might have another script for redeploy. For whatever reason, if you need to redeploy a service, the device crashes and burns, and you need to put a new device in, and you need to redeploy the service, right? So you need another script for that.
Classic example could be the mobility deployment that we have done, right? I mean, one SAR, which is a hub node, and then layer 3 VPN from every cell site to the same mobility gateway router, right?
Correct, right? And not just that, Girish, we can even do more funky stuff. You can even, using FastMap, as you will see in the next slide, you can migrate from one platform to another platform, right? From one device to another device. And I'll show you how you can do that in a second when we go to the next slide. And on the NSO side, you just have to do the one creation mapping, right? Just one script. Not script, but we call it a mapping, a FastMap, but just to show you the comparison. And this is how you're getting your 90% saving. Imagine if you add a new platform or new device or a new technology. Now, in a traditional approach, you have to go back and change the create script. Then you have to go back and change all the modify scripts, or change or add or update or add another one, I guess. Delete, add another delete script, add another redeploy script. With NSO, you add the new NED, and then you add one more mapping, right? One more FastMap mapping. And so that's how we have the savings, right? All these add up to that 90% saving. The auto generation of your APIs from your model, the automatically inferring the update and the delete and the redeploy from the creation mapping, the automatic rollback on failure, transactional guarantee, all that is saving you a lot of script, a lot of hard work. And as I mentioned, writing these scripts is the easy bit. Tomorrow you go and you do something different, some person new comes along and they have to maintain. Imagine if they have to maintain it, right? So the more code there is, the more bugs and more maintenance costs, right? So that's what we're trying to minimize with NSO here. If we can infer something like FastMap, it'll infer that for you. So you don't have to write scripts for that. And this is where now you're seeing the benefit of the model-driven approach. So how does FastMap work if you think about it? If I go back to that slide, when you make a change, say you make a change in your source IP or you make a change in your UDP, what FastMap does is it reruns the creation mapping and it will get a new output on the right. And then it will compare the new output on the right with the current configuration of the device as in the configuration database in the CDB. So it generates the new config and then the new model, and then it compares it with the CDB, the current status in CDB, because they both are model, right? Because the new output is a model, because it's from the device model, and the current configuration is again expressed in Yang. Doing a Yang to Yang diff is really easy, and that's how it can figure out the minimum changes. So it figures out that, the device configuration, this needs to change, the minimum diffs, and then it gives it to the net engine, and then the net engine pushes it to the device. So you can see how the benefits of model-driven architecture start to flow on when it comes to the creation mapping. If we hadn't gone and modeled the entire network in Yang, you must be thinking, what's the point of modeling everything in Yang? That's the benefit. Once you do that, you get that precision, and now you can do delta diffs. You can compute minimum changes, minimum diffs at any time. Even if someone goes and changes the network, that's another example actually. If you have Maruti configured like this, right? You have Maruti, you configure Maruti, you push configs to your device. Someone comes on the device and changes the source address on the device, right? They tamper with the configuration. Now, how would you detect that with your current tools? How would you know that someone has come and actually changed or tampered with the device configuration? With NSO, what we can do is we can go at NSO and say, hey, do a service check sync. So we can do a check sync of the service, right? We can go check if Maruti's VPN is still in sync. And then it can do the delta diffs with the configuration on the device and the configuration it expects to be on the device, and it can show you the line-by-line diffs. So these are some of the benefits that you get with the model-driven approach. Right. So let me just skip over any questions? Okay. So let's continue. I just want to finish this deck today just to give you some, maybe we'll stop at some stage. Let's just do maybe 3 or 4 more slides, and then we pick up tomorrow, okay? Let's do a few more slides. These ones are going to be hopefully faster. So as I mentioned, the first thing that you do is the service model, and here I have just picked up some random service model that I built. Again, you might not agree to it. You might say I might model my service differently. On the left, I have a layer 3 VPN example. On the right, I have an NFV service example. Without going into the details, as I mentioned, the service model is about the outcome that we want. We want a VPN for a customer, for a tenant, and we want to have the minimum parameters required. Now, you might argue, so let me just go down this. So a list basically means we can have multiple elements, right? So it's a list of layer 3 VPN, so we can have one element for Maruti, another one for, I don't know, Holden or Ford, whatever cars you have, Volvo, for example. So a list, you can have many elements. Then for each of those elements, you have to supply all the values, right? So you got to supply a name. So the name could be Maruti or it could be Volvo, for example. Then you have to supply an AS number. And when you supply these parameters, they have to abide by the validation that has been put in the Yang. I have collapsed that now, but we'll see some in the lab where we can put in validations so that garbage cannot enter into the system. So the earlier we reject the garbage, the better it is. So the idea is at runtime, we never let garbage go into the network. We block it out. We do validation at the Yang level, we do validation at the service level, and before even we touch the network devices, right? Because the earlier that we can pick issues, the cheaper it gets. If a config goes out in the network on a device and we have to go back and debug that, you know how hard it is, right? So instead, we put all the smartness in our service definition and service mapping, and we test it, so we ensure at runtime we never let garbage go to the network devices. And then we have a list of sites. So for every tenant, for Volvo, we can have a list. We can have many sites. Each site would have a name, a device, which is the PE router, a link where the CE is attached, the VLAN ID for the traffic for your, coming from the CE, where it's tagged by this VLAN ID, and then an IP address for that subnet. So we can do any, routing, peering of the routing between the PE and the CE, for example, right? very simple example here. You might argue, some of these things we might be able to auto-generate. I don't know. You might say VLAN IDs, can we assign them, and can we use plug and play to push that on the CE side as well? Definitely we can, right? This is just an example. IP address, can we get it from a pool? We have a pool of addresses, and can we get like a /30 or something from the pool and assign it? Definitely we can do that. And by that we can eliminate 2 parameters, so the operator doesn't have to worry about it. The operator doesn't have to go and look in a spreadsheet to see which ones are used or not used, right? So you remove all that and you get full automation by using by allocating some of these values from a pool that is set up at setup time. And then what you do is, once you have your service model, then you map it to your device model. And in this case, this is a device model for Juniper. And we are just mapping the parameters from the service to the nodes in the device model. And here the device model is represented in XML simply because we are substituting data from our service model into our device model, right? So that's why it's in XML. And when we do the lab, this is what you'll be doing. You'll be getting this device model, and you will be substituting values from your service parameter into your device model. And this mapping here is called the creation mapping, right? So the device model on the right comes from Cisco, from the NED package. What you all have to do is do the service model, which is this model done in Yang, number 1, and you have to do these mapping. You have to draw these arrows from the left to right. So those are the 2 things that you have to do. And the service model, which is the Yang that you see over here, and the mapping, these arrows are stored in your service package. So the service model and the service mapping, the fast map for your service in the service package, the device model, and the NED engine goes in the NED package. Now this file that you're seeing here on the right, this is actually the mapping file. It's not the Yang model itself. This is the mapping file, and this mapping file is actually part of your service. The mapping file, these device and name and config configuration interfaces, VLAN tag, all these abide. They abide by the Yang model for the Juniper, right? So the Yang schema is in the NED, and this is just the mapping file where we are basically mapping the service parameters to the device nodes in the device model, and this is the mapping file. So this goes in your service package, right? And this is what we'll do in the lab, so not to worry about it. We'll go into.
So Bilal, quick question.
We'll go into that.
Could it be the case that I just use the XML template and use NSO as a deployer? I mean, assume that the mapping is already done to some external entity.
Correct. Yeah, that's pretty much what we do. If the mapping is already done, then we just use the XML template and we just deploy it. And not only that, because we have FastMap, we only need the creation template. We don't need the update and the delete. That's automatically done by NSO. We only need the creation one. So it saves time, and without really losing accuracy, it actually gives you more accuracy. When you use the template, XML template, as your mapping file, then NSO would use that and push it to the network, and then it will remember, it'll have the mapping that for Maruti, these are the devices I've touched, and this is the config. So when you do a delete, it knows the config and which devices were touched and what configs were pushed on those devices, and it would remove them as part of the service decommissioning. So you don't have to schedule another time for decommissioning, because we've had service provider, they leave all the decommissioning for later because they don't have time. So they leave the decommissioning and then they do it in batches. In NSO, you just go no layer 3 VPN Volvo and say you want to decommission a site, so you go site X. That's it. You don't have to go device by device, config by config, remove it. So definitely you can use the XML template and use that as your mapping file and save yourself from writing another script for update, another script for delete, another script for redeploy. And also you can use the same mapping file for auditing. So if you want to go and audit and see if the service is still as you expect it to be, if the service has changed, then NSO will tell you that someone has changed Volvo's configuration on PE55, and these are the lines that have been changed. Give you the delta diff. So that's really what you're getting with NSO.
So for a brownfield customer like Reliance, right, wherein a lot of work has already been done with, say, some 800, 900 odd templates, would it make sense to go down this path, or should still, do the earlier steps that you described and then come down to, this particular milestone and then say, okay, now NSO can work as a deployer? Or say maybe for anything which is going in new, say for a different part, right? Say for example, wireline services. We start this way, come and create the mapping and all those things. But where the mapping already exists by virtue of business logic or some other work already done as part of a configuration template, we leverage that and go ahead with this approach for the brownfield part. Or can we have both greenfield and brownfield in one deployment?
Yeah, I mean, we can, but I agree with your approach, which is let's do the greenfield first. I mean, because it's an initial insertion in Reliance, so I would do the greenfield. Now, when it comes to brownfield, we have something called service reconciliation, which means if the service instances have been configured using a well-defined template, then we can build a service package and we can bring that service instance in NSO, and subsequently we can do the create, read, update, delete for those instances via NSO. Provided that it has been done using one of, let me just, guys, if you don't have any questions, if you can mute yourself, then that would be great. So with the brownfield example, we have something called service reconciliation, and the effort required to bring all those service instances in the brownfield into NSO so that the subsequent operations on those service instances can be done through NSO. It depends on the number of variations that they have used. If it's the one template they've used and they have made sure that they have used the same template again and again without someone going and changing manually, then the reconciliation would be very easy. But if there are multiple variations and people have, gone away from the process and they've done some strange things on top, then those things, at the time of reconciliation, they will pop up and we will have to, manually fix it up. So that's really where the problem comes. If someone has gone and manually changed the configs over and beyond what the template would have put in, because then they become like anomalies, right? And we have to resolve them before NSO can take over that service instance. And if we have time in the lab, maybe I'll show you how to do service reconciliation, where we know the configs on the devices, we know how the configs looks like, we have the template, then we build a service abstraction, and we map that service as per the configs that we already have in the network, right? So we do the mapping, and then we discover these services, and then we bring them under NSO, and then from then on we start provisioning them in NSO, right? So this is something we call service reconciliation, and the effort required for that greatly depends on how strictly we have been following process while using those templates. If there's too much diverging cases, then for those cases we won't be able to automatically redeploy. We'll have to do a little bit more reverse engineering there. Okay, so we keep going. Now, when you have another vendor or another platform, or you're doing a migration from one platform to another platform, then what you could do is you could add another net package for B, platform B, and you could add another mapping from the same service model to the new net, the new device model that is being exposed by the NED, right? So you just add another mapping. And again, you just need one mapping, the creation mapping. And again, the update and the delete and the redeploy is going to be automatically inferred by FastMap. So you can see that this process is linear. You don't have to write scripts after scripts. Just one script, or one mapping. I wouldn't call it a script, but a one mapping from your service to your device model. Now, what are the benefits? The benefit is if you have done your service model in a device agnostic way, platform agnostic way, then your service model doesn't need to change. All you need to do is add the new mapping. As a result, your OSS, BSS integration doesn't need to change because your service model hasn't changed, right? The APIs, which as I mentioned are auto-generated for the service, doesn't change. The CLI for that service doesn't change. The web UI, the Python binding, the Java binding, the REST, the netconf, the JSON RPC, whatever interface you're using, right? So that's why it's very important not to
so Bilal,
bring in.
Where do I put my if then else kind of conditional statements then?
You don't put if and else. So what happens is in your service you might have a parameter called PE device, right? You might have a PE device, and then you might have then you go back in your service instance for Maruti and you say I don't want to use PE device Calcutta. I want to use PE device Mumbai, for example, right? Now, the new PE device happens to be of type B. Now, when you go to NSO, okay, I want to redeploy my service, right? Now, NSO automatically would go, this device that I have to push my configs to is of type B, so it would use this new mapping to generate the configs. And it would go back to the device A and it would remove the configs that it had pushed earlier. So that's how you can do a migration, for example.
So the scope of every deploy activity, right, whether it's redeployment or a first time, is very local and restricted, right? Every time I want to do a change or whatever, it is again going to be very local change for that part only, and there is no state information being preserved as such, correct? That's why there is no if then else.
No, yeah, there's no if else in this case, definitely. So, from your perspective as a service designer, all you have to say is, this is my service model, and this is how it maps to device model A. And then you add another mapping and you say, this is how it maps to my device model B. Now, from an operator perspective, they would just continue to do what they're doing, except this time around, for their PE device, they'll pick another PE device, and NSO is smart enough to know that, hey, this new PE device is of type B, so I should use type B mapping and not type A mapping. So you don't have to do if else. NSO would know that because it knows when you add a device under NSO, you have to say this device is going to use this net package, for example. So if you're adding iOS, you say this is the iOS device, this is the management IP, and this is the net it uses, iOS net. So when you pick that iOS device, then it knows which mapping to use automatically. So from a migration case, you just have to point your service, the node in your service for Maruti, you have to say, instead of PE1, use PE2 or PE3 or whatever, and NSO would know which mapping to use automatically. So the service designer just has to add the different mappings, right? So that's, from a high level, that's how it all fits together. I mean, look, there might be a reason why you might want to do if else in your service creation callback, as I mentioned. There might be a reason, you might want to do some checks and balances. So you can do if and else. I'm not saying you can do if and else if you need to in your FastMap using Python or Java. But for the migration use case that I was talking about, or if you want to do a hybrid environment where you have some PEs which are platform X and some other which are platform Y, but you don't want the operator to have to be exposed to that level of detail. You want the operator just to supply the parameters for the service and be able to provision that service in a uniform way. Why expose that to the operator and why make him, supply the CLI? Let him just give the service parameters, and then NSO would figure out which mapping to use depending on the devices that has been chosen for that particular tenant. Okay, so this slide is again an example of reusability with software-defined networking. You hear a lot of SDN and all that. to me, software-defined networking is applying the concepts of software towards networking, things like repeatability, modularity, openness, interfaces. And that's really what NSO is doing. With stack services, what we're saying is you can have a stack of services. So you might want to have some common services that can be reusable, and then you might have higher order services that might consume the one or many bottom level services to get an outcome, right? So we can stack them up. And again, when you do the stacking, you only have to provide the creation mapping. So you say, when I'm creating my top service, this is how my top service maps to the bottom service. So you draw lines from left to right. And then as part of your mapping for your bottom service, you would say, this is how my bottom service maps to device A. And then you want to add another device, then you map your bottom service to another device model or model, right? So you can stack them. You can have, in this example, I've only got 2 levels of service stacking, but you can have n level of service stacking. You can have n level, 1, 2, 3, 4, 5, whatever, as many level. And every time you have to only define the fast map, and the last service layer would then map to the device models, right? This allows for reusability. This allows for the whole object-oriented concept where a bigger service is composed of many smaller ones. Instead of redefining the same bottom service again and again as part of multiple services, you can abstract it out, and then the top services, different types, would use that to get that outcome. So it could be, for example, I don't know, a routing service or a firewall service, and then the top service could be a bit more comprehensive, which might use many services to offer some sort of higher order outcome. I don't know. I'm just saying this is something that can be done in NSO as well. Layering of services, and FastMap applies equally when we do the stack services. Okay, so this is going to be really fast because I've already covered the benefits, right? Number one is auto generation of APIs and auto generation because of FastMap, right? So you know how much time you're going to save, right? You don't have to write any logic for your APIs. APIs are automatically generated. Not only one kind of API, many kinds of API. Which one you choose depends on your situation. Different APIs have got their pluses and minuses. We can go over that in the lab where we say, what's the benefit of RESTConf for NetConf? What's the benefit of JSON RPC? What's the benefit of REST? They've all got their pluses and minuses, right? So we can go over that. And similarly, FastMap is saving you a lot of development time, right? Less code, less headache, less bugs, easier to maintain, cheaper in the long run, okay? The second one, already mentioned, precision and traceability. At any time, you can go from a service instance. So we have a Volvo, which is a service instance. We can trace it all the way to the line of configuration on the device or devices, right? You can trace it all the way. And vice versa. You can go from a line of configuration on a device and you can trace it back all the way to the end customer that it was configured for. So no longer are you in a situation where you're too scared to remove a configuration on a device because you don't know what impact that will have, right? So there's so many ACLs that we don't want to touch because we don't know who put it in there and what damage they can cause. So, we leave them forever. With NSO, they're traceable, and when Volvo is removed, because of the model-driven approach, all the lines of configuration from the network are going to be removed. That's how, because of the precise mapping, right? So you get that precision with NSO, that really deep surgical precision. I've already spoken about transactional guarantees. When you're sitting on top of NSO and you're an operator and you're making changes and you have a change set, you might be provisioning a few service instances, updating a few service instances. You might be doing a whole lot of different change. Now, once you're happy with your change set, which might be touching 1, 10, 50, 20, whatever devices, once you're happy with your change set and you hit the commit button, then NSO gives you a transactional guarantee. What that means is if any of those 50 devices fail, then NSO would roll back your network back to the state that it was in. So the network always moves from a consistent state to a consistent state. How big your transaction is going to be, it's up to you. How big, how many devices you want to touch. We had a customer in Japan, they were using NSO on top of APIC, and they were pushing 100K lines of configuration on the APIC in one transaction. I'm not saying you should do it. The problem is that if anything fails, then NSO would roll back. So it takes you an hour or whatever to push the 100K configuration, and it'll take another hour to roll back. So, you should always try to make our change set sizable so that, it makes sense of what we're doing. But having said that, you can have your change set as big as you want, and NSO gives you that transactional guarantee. Your network is always in a consistent state. You don't have to write extra scripts and templates and code to check if your changes have been correctly configured in your network. You don't have to write rollback. If something fails, you don't have to go back and remove half-committed operations in your network. It's all done for you. You don't have to write scripts to do your error checking and sanity checking and auditing of your services. NSO can do auditing in real time. It can do it in real time and tell you which services are out of whack, how, what has changed, and you can even tell NSO, hey, the services that are out of sync, bring them back in sync, right? So it'll bring them. It'll go and fix up the configuration. It will apply the delta diffs. Always NSO does delta diffs. It doesn't remove everything and then put everything back. Rather, it can compute the minimum changes so your network converges a lot faster because it has got the view of your entire network, view of all the devices and all the configuration. It can compute the delta. For example, the template doesn't know what configs are on a given router. So you just blindly push the template onto the router. With NSO, it knows what configuration is already on the device. So it doesn't need to send them again because it knows it can optimize that. It always sends minimum diffs to your device. So whenever you want to make a change, it can compute the minimum configuration changes required in your network, and it would push those configurations in a transactional manner. And lastly, there's no hard coding, right? So we don't have any hard coding in NSO. The sort of services that we can build in NSO, and tomorrow we will go through the demos for these services. I will do a demo for each one of these use cases. So here you have, NSO doing layer 2 VPN on a multi-vendor network, right? Then you can have layer 3 VPN on a multi-vendor network. And these are traditional use cases, right? We see them all the time. And then you might want to do some more use cases like a cross-domain use case where you want to do from a single touch point, you want to do APIC controller, configure that, and also configure the ESR9K in transactional manner, so, cross-domain. So we have NSO doing, I have an example where NSO is doing just that. So there's no limitation. It's really up to the creativity of the service designer, right? And then we can go into the more NFV use cases where we're doing both. We are provisioning and activating services in a multi-vendor physical domain, and we are also provisioning and activating services in a virtual domain. Not only are we activating, but we are also managing VNF lifecycle. We are spinning up multi-vendor VNFs. We're configuring those multi-vendor VNFs and multi-vendor PNFs to get an outcome, to get a service. All that from a single touch point. And again, you can do that through CLI, web API, any of the northbound interfaces, right? So there's no limitation there. This is another approach where we put an NSO per domain, one NSO for the MPLS domain, one NSO for the data center domain, and then have a master of masters sitting on top. And sometimes we have to do this because of administrational boundaries. Different groups have got different administration boundaries. There might be internal politics within an organization or whatever. So we can do a master of master, and we can have multiple NSO instances. And again, the adapter tax and the integration tax here is 0. Because everything is based on netconf and Yang, we can take a service model from our MPLS domain and drop it into the master of master. Similarly, we can take a service from our data center domain and drop it in the master of masters. Now the master of master can stitch together a service across these two domains, and you don't have to write any code for that, right? So it's all done simply from the fact of using netconf Yang. And again, I'll try to show you this use case in one of the demos that I do. Okay. For some of the customer in US, we also use it for PCRF and PCEF policy coordination. It's the people who do this, how difficult it can be to do the PCRF, PCEF coordination with a lot of with a lot of Excel sheets and comparisons and things like that. The main idea here is you should see the breadth of vendors and network elements that are being configured and the variety of interfacing that has been used here. So you can see SSH, SOAP, REST, netconf, F5, affirmed networks, NFV, physical, virtual. So you can see really the power of NSO, single touch point to activate your services across multi-vendor, multi-domain, hybrid sort of environments in a transactional manner, with complete precision because of using, a model-driven approach. And again, same concepts, bumping the wire sort of services where we have switching on, or configuring different network functions from different vendors to get an outcome, right? So all those NEDs give you these device models that give you the capability of programming anything and everything in your network to get an outcome, by just using a simplified Yang-based interface, right? And alongside you get the Yang-based high precision as well. So you're not losing any precision. This is not like a banded solution where we're sticking together scripts and all that. It's a very precise model-driven approach to configuring. Give me a sec. Let me just mute someone here. Okay. So this is not this is not like a banded solution which is stitched together. The whole time it's top-down, bottom-up, model-driven, precise mapping, full traceability. When we decommission service, we remove all the configs. At any time, we can audit the config. So you're getting a really precise and mature sort of solution here. And I think that's pretty much, okay, so this is just a use case we did for a public, this is a public reference, so I can tell you this was done for SoftBank. And again, the main idea here is look at the services that are being offered. It's a physical and virtual environment that is being programmed, and it's a multi-vendor environment, right? So you get physical, virtual, multi-vendor, cross-domain sort of outcomes with NSO. And this is a public reference, SoftBank. You can Google it, and you can see how NSO is helping them. They went from it took Cisco 6 months to build this, from idea to take it into production. And now that it's in place, it used to take SoftBank a month to take an order, and then they would manually provision it. And now it happens instantly. They take an order, and it gets provisioned instantly across their multi-vendor, multi-domain environment, and and they offer a whole suite of services. So it's sort of like a self-serving portal. They're going to start to expose some of these services to the end enterprises. They can come and activate, for example, remote access into their VPN, via the internet, or they can access internet access from their VPN sites automatically by doing, the admin for the enterprise can do it on their own without getting the service provider involved. Again, business impact, speed and agility, how you can bring new services. You will get 90% saving when compared to the approach that I mentioned, the traditional template script-based approach, because of fast map and auto generation and transactional guarantee. You get cross-domain activation. You've got a model for everything in your network, right? So you can do cross-domain stuff. You've got a single touch point to control your entire network. And as I said, the model-driven gives you that surgical precision, single source of truth. And that's it for today. It was a long session. I was hoping we could do it in 1.5 hours, but it took actually 2.5 hours. So, I did underestimate how long that would take. But I think it was important to go over the high level of NSO, what it does, what's it capable of. So that now you get the context, and when we go into more details and hands-on lab, then you will be able to relate back to the big picture. It's important to have the big picture before we take a deep dive. Any last questions that you might want to raise? Comments, suggestions? Am I speaking too fast? Shall I slow down? Any comments on that? Any feedback?
Anything? Any question? Thanks, Bilal.
We'll be reconvening tomorrow. So if some questions come up, definitely bring it up tomorrow. And all these recordings are going to be posted.
Hello, Bilal. Can you share that PPT with us?
Sure, not a problem.
Yeah.
We'll share. I'll pass it on to Krishnaji, and Krishnaji can pass it on, distribute it to everyone.
Yes. Thanks, Bilal.
Okay, thank you, everyone. Let's talk tomorrow. Thank you.
Yep.
Bye.